It's in the standard distribution since 3.10, and I will try to explain you how it works basically. So first in an introduction, then three kinds of projects that OCamlBuild can handle, and with three levels of difficulty to use it, and then some more general features and a conclusion. Why such a tool? Because we want to write camel code, and writing make files is not a so good idea, because often they don't really are right. Don't have to type make depend or make clean sometimes to make it work. We want to avoid this. That's the kind of tool that we want today. So, what kind of project? We will classify OCaml projects in three kinds of projects. Regular ones, basically, I will explain later, but that's the major part of your project. That's just ML files, etc. I will explain it a little more. And these projects are very handled automatically by OCamlBuild using just one command line. But often we have some exceptions, because there is rules to compile camel, and there is exceptions. I want debug flags here, I want this syntax extension there, etc. So we have a full mechanism for this called tags, and it's very powerful, but a little bit tricky to get the first time. So I hope that I can explain you this part. That is I think the most important feature of OCamlBuild. And then since we want to handle any project, or because you have some rules in your project that are very different from the classic style, we can extend the tool using plugins that are pure OCaml code and not rules in a new language like make. We wanted to avoid adding a new make language. So, what does OCamlBuild provide? So it's automated work project compilation and recompilation, minimal recompilation of using dependencies. You can do other things that compilation, like documentation, debugging, profiling. It supports by default a build directory to don't clutter your source directory. The good point is that you can have multiple build directories for different targets. One for debugging with debug flags, and another for profiling, things like that. You gain an automatic and safe cleaning, since almost everything is in the build directory. And have a tool that is quite small and to be shipped with OCaml to save time and money for. So what's a regular OCaml project? It's a project without exception to standard rules of building OCaml. So you can have ML and MLI files, you can have lexers and parsers, you can you can use package in the sense of -pack, module package, libraries, top levels. You can link with external libraries. When it's global, it's quite easy. Then it's the second part, and you have a main entry point to tell OCamlBuild to start from this point. So you can have your main.ml, and you say I want main.byte, and you will get the whole compilation and link done by OCamlBuild through an automatic way of discovering sources and compiling them. Why it's difficult? Because OCaml has some subtle rules. Because interfaces can be absent, sources can be absent if there is only types in the MLI, but you can have absent MLI files, but still buildable. So it's not just having rules that say, oh, if there is no MLI, I do that. No, it's really you must try to build it. There is native code and bytecode, and some subtle things change between the two. There is packages that are quite difficult in native code, because you have to specify in what package the module will be, and it's completely non-modular. So it's better if it's handled by the tool. You have to compute the right linking order. Also, the order of include directories matter. And OCamlDep can't give us a complete information, but only a partial one, because we can't do a full typing in order to give the right dependencies. So it's a superset of possible dependencies, and it makes things a little more complex. So it's another reason to have a tool to handle this. So since there is all these rules, we wanted to have some standard library of rules that we don't override at each exception, like in Makefiles. You have a rule, and oh no, it's not. It's a special case. So you have to make a specific rule in Makefiles that override that one, and you have code duplication, or you can use a lot of variables to share parts, but it's complicated. So we have a standard library that we don't want to extend in the classic way, but we have a tag mechanism that to extend it properly. OCamlBuild does a dynamic exploration. It starts from a target and discovers dependencies, uses OCamlDep. So there is a little backtrack mechanism, because you can have rules to build something, and then you hit. You know that you can't build this particular target, so you backtrack to another one. It's a little. I think it's unavoidable in OCaml today. So we have this little mechanism, and then there is this dynamic dependencies discovering. So we run commands, we run OCamlDep during the process. That's not some task that we do first, like make depend, and then one can build. OCamlDep is really incrementally used to compute new dependencies and use them. Okay, that's for regular OCaml projects, but 90% of OCaml projects are regular, but there is always this 10% of exceptions that are for debugging, profiling, if you want type annotation, if you have some module that use recursive types, some binaries that need to have link code, some C code, some custom threads from some of them. So we have this mechanism to specify exceptions to the rule. We have rules that are in the standard library, and we have exceptions to say, oh, this particular module requires this flag, and we have a quite fine-grained mechanism to do it. Okay, I already said that. So in Make, you have to make more specific rules to encode exceptions. But basically, it don't scale. This mechanism don't scale. Okay, our way is to use tags. We tag files in the underscore tag file. Each line, like in this example, on the left-hand side, we have languages of files. We can use Booleans operators like or and not. We have constant strings, and we have globbing like in shell with brackets. And then on the right part, we tag something. For instance, the funny.ml module file use rect types. So it's quite declarative, and yes. Perhaps we should look at the second part. That is, basically there is three ingredients in this mechanism. First, files are tagged. Then there is rules. For instance, for OCaml, there is this standard library of rules that make a command. Like here, there is OCaml C, -C, and some placeholder to add new flags. But since you don't know what flags to put here, you give a set of tags that specify what kind of command you are running. So here you are saying that you are compiling caml in bytecode. You have OCaml compile and byte tags, and all tags that are specific to the ML file. And then you give your arguments. So you have commands plus placeholders, target placeholders. And then finally, you have some exception declarations, like here, when one compile caml in bytecode, and that rect types is here too, we add the -rect types flag. So the combination of these three things makes that foo/bar.ml will get rect types at bytecode compilation, basically. One can also specify dependencies this way. It's like the flag declaration. So here you specify files that we want to be present before running the command. So here, when one link some OCaml bytecode program and some specific program that is the foo plugin, then as these files must be present. So you have dynamic dependencies that are added this way. And then this will concern the test.byte file because it's tagged plugin foo. So most of the rules are in the standard library. So, and most of the exceptions, like common ones, like types, debugging, etc., are also in the standard library. So, basically, many projects, it just to handle many projects, it's just adding tags, tagging some files with your exceptions. When you want to add new rules, add new exceptions, add new dependencies, you have to write it in OCaml, like here. It's the first box, or the 2nd one. It's classic OCaml code. And we call this plugins. So it's not specific language, but plain OCaml code. Plugins are compiled on the fly. So one can do some dynamic configuration depending on the host machine to set different rules. So what can do a plugin? Can extend rules, add new ones, override old ones, add new flags and dependencies, like the declaration seen previously, tags files, change some global options, define directory structure precisely. I mean, when you want to say that this directory see the content of this one precisely, in order to don't give your minus include flags globally and neither for each file. But it's something that you define once and can be very useful. You can also help OCaml dev by telling him that no, this file don't depend of this module. It's just because of there is the same name, but that's a local one, but you can't guess it, so you can help it and specify some external libraries, things like that. There is also some general features like parallel execution when it's doable. We can do something better than we do now, but basically it works for projects like you have some separate compilation that is easily seen by OCamlBuild, because it will first compile all your interfaces sequentially, but then in order to do the link operation, you will see that you need a lot of CMO in one time. So it will parallelize the building of these tasks. Okay. We support also some other tools like Menhir, because Menhir, especially Menhir, because it requires more fine-grained dependencies, because you want to type check your parser. So there is this -infer flag that makes files crazy. And in OCamlBuild it works well. So it's a good point. We can also automate the use of OCamlDoc. Can help to generate some HTML, LaTeX, man files quite easily. And also OCamlP4 flags and exceptions that will make things simple. Okay, I don't talk about. We have also this nice progression bar to avoid a long and lengthy outputs, but something that is more readable. Okay. In conclusion, there is three levels. The first one is for regular projects. So the biggest part of your project should be something classic. Then you can specify some exceptions very precisely using tags. And for specific rules and specific projects, you can extend the engine with new rules and specific rules. Finally, OCamlBuild saves you time by building your project, compiling only what's needed, running commands in parallel, keeping your source directory clean because it's always use a build directory in order to let you concentrate on your code. Thanks for listening. If you have questions. Yes?
I have two questions, both of them related to OCamlP4 actually.
Well, no, it's not me.
No, I mean OCamlP4 inside OCamlBuild.
Okay.
First question, I have the impression when I'm OCaml building something that OCamlP4 is invoked every single time. I mean, once for OCamlDep, once for OCamlC, etc. Some preprocessors, such as Anafrish's Ulex, do take some time when it's with big files. Yeah, well, yeah. It's lots of work. So, is there a way to cache this?
Yes. You can, in first, having some ML4 files, you can use a new extension and use a rule to say that you can go from ML4 files to ML files using the right OCamlP4 invocation, and then saying that your ML file is just classic. So it will be pre-processed once to either source, an OCaml source, but you lose locations, or directly the marshaled AST that can be in a ML file too. So it works that can work that way. There is also we also try to make a cache a preprocessor caching command because OCamlP4 was slower and slower at some point. It's finally no longer the case, so we don't maintain it. But basically, it's in the OCamlBuild directory. There is this pp cache thing that can help you.
Okay. So that's an example of a plugin, is it?
No, it's an external command that you just call pp cache and then the preprocessing command, and it will look at the inputs, do some hashing to fetch the file in the cache if it's already preprocessed. It's not really. There is some plugin to say that, oh, don't use OCamlP4 but pp cache OCamlP4, but that's a global option.
Okay.
Another answer would be that if you're not happy with the performance of OCamlP4 in bytecode, you can run OCamlP4 in native code.
Yeah, well, okay, but sometimes when you need to compile regular expressions, you need to compile regular expressions. I mean, it will take some time, even if it's 10 times faster.
That's probably okay.
Well, I actually don't know which OCamlP4 is invoked by OCamlBuild by default.
From the
bytecode. The problem is that most of the users use some extensions with OCamlP4, and since we don't have yet released the version with native dynamic linking, we can't make interesting uses of OCamlP4 in native code today. So basically, it's in bytecode by default.
Okay, so that won't happen. There was a second question, which was related, but I mean it can be useful for people who don't need OCamlP4 too. Okay, in the wiki, on the wiki there is an example on how to use OCaml findlib with OCamlBuild. No, that works by replacing ocamlc, the ocamlc command, by ocaml find ocamlc, which is good if you're using ocaml find for every single file, but obviously not if you only need it for a few files. So is there a solution to that? Or rephrased, what I wanted would have been to make a plugin with basically the equivalent of quoting in shell. I mean, get the output of ocaml find, that gives me a directory, and that's enough for me.
Okay, that option is possible too. You could make some calls to ocaml find to extract plugins, to extract flags, and inject them using flag and dependency mechanism. I think that's also feasible to specify that you won't have run ocaml find, ocamlc for some files that are tagged with I use ocaml find. I think it's a little tricky because basically it's not like an option, not like a flag. I'm not sure it works if it works out of the box, but
well, I can still ambush you at some point and try to.
Other questions? Yes.
I've got another question also related with OCaml P4. So my use of OCaml P4 makes that sometimes in the projects I try to start writing and sometimes end, I have some OCaml P4 inside the project. So I have OCaml P4 dependencies, and my first tries with the ocamlbuild made me think that the only way to deal with this dependency of OCaml P4 code that will be some later syntax extension is to use make. And then I stopped using OCaml that way.
It's certainly not as clear as I want, but it's really the point of OCamlBuild to discover dependencies, and then to have something that, oh, I have to build this extension in order to build this file, in order to even know dependencies of this file, because OCamlDep will need the parser, so need the extension syntax, so you really can do that. Basically, it's done using dependencies declaration. You will tag your file, use this syntax extension, and you will have a flag that will say, oh, add this CMO to the OCaml P4 command, and a dep declaration saying that, oh, but this CMO must be built at this point.
So is that mainstream, or is that a plugin to make?
To OCamlBuild.
Yeah.
You have to write a little. There's two declaration plugins in your OCamlBuild saying that for this extension, syntax extension, you need to add this flag and to have this CMO, but it's mainstream.
Okay.
And I think there is in the wiki.
I think there is an example on the wiki.
There is an example in the wiki.
That was one of the main motivations for writing OCamlBuild in the project. I think we should make
more explanations to make it clear, because
that's really try and succeed in compiling the code processes using OCamlBuild. And we'll answer all questions. Because exactly this issue with compilation of code. So you should do that. And
I spent some time on doing it, but not have full time to do it. But we compiled the whole OCaml distribution with OCamlBuild, and it's not a simple task either. But it's for Coq, it's really I think it will be really addictive. Yes.
Just one question. Why do you choose to distribute OCamlBuild with OCaml?
that's that was our volunteer to do it because of two reasons. The first one was to be able to use this kind of tool for building tools in OCaml itself, like CamlP4. If I want to use something other than make in order to build CamlP4, I need something that is inside the distribution, and it's personal. But I think that the whole OCaml community deserves something like that. I think it's for people that make libraries and projects. It's really frustrating to say, oh, I use make, or I use let's say OMake, and force my users to have this tool installed on their machine. I think it's
yes, but you create, in fact, by adding things to the core OCaml. You create a bigger source code with.
Maybe I can take that. So,
yeah.
So yeah, the primary motivations was because when Nicolas wanted to use it for CamlP4, and for good reasons, the makefile for CamlP4 were getting extremely messy. And since CamlP4 is in the distribution because it accesses internal files of the compiler, by transitivity, we ended up with OCamlBuild in the distribution.
Okay.
And
thank you,
there was
Xavier.
also some interest in using OCamlBuild to build the whole.
Okay. But I think we just have come back to the.
I mean, the makefiles we have today sort of work, but are not ready.
Yeah.
So maybe at some point we will also want to have something better. I guess these were the two motivations.
I think we come back to my question of this morning about internal data structure and something complicated to develop tools about OCaml outside of OCaml. So okay, I understand.
Yes. No more questions?